Hello everyone, how are you? I am fine, thanks to God. Now today we discuss about searching in algorithm in the data structure. What is searching mean and what types of searching are there? So after we define or introducing the highlight what is searching, and we see the first one, linear search, and how we implement using C++ programming arrays, using arrays. So searching is why do we study sorting and searching in algorithm design? As we know, so these algorithms are the most common and useful tasks performed or operated using computer systems. In any computer system, searching especially is a very key critical operation. So now computers spend a lot of times for searching and sorting items. Searching and sorting items. So what? The first one is the simple search algorithm. The first one is simple sort algorithm. So what is simple sort algorithm? Before that, searching is the process of finding an element in a list of items or determining that the item is not in the list. Check the item, the required item list is found in a given array or list or not found. This is what is searching. So to keep things simple, just we shall deal with a list of numbers, and a search method looks for a key. The y or the thing that we want to search is called key, or the target value or item arrives by the parameter by convention. The methods will return to the index of the element corresponding to the key, or if it is not unsuccessful, returns -1, or the key is not found. The key is not found. So what? There are two types of simple searching algorithms. Commonly, we have two types of simple sorting algorithms. The first one is simple sequential search. Simple searching algorithm. The first one is sequential search. So how simple sequential search algorithm implemented or applicable in our computer system? So the sequential search, how sequential searching is implemented or work in our computer system. So what is that? The most natural way of searching an item, the most natural way of searching an item from a given environment or a given container is simple or sequential search. So easy to understand it, easy to implement. The way of implementing it and acting is very simple and easily understandable. What? Linear search. So the algorithm is implemented like in a linear search. We start with the top and beginning, the top or the beginning of the list, and compare the element at the top with the key. So if we have a match, if we found or if you get a match, that means the list of array values is equal to or corresponding or congruent to that of the required target value, the key. Check it, and if not, we go on the next element in the list. If the matched comparison of the two, the key and the list of first item is matched, the key is found as the first time. If it is not, go to the next until the list of items in the container or in the array is empty. Let us assume this is a C++ program. This is a C++ program implemented using C++ programming. What you have to do before creating the list of arrays, just I show you how we declare or create the function. So at the beginning, import the iostream.h, then int linear search. We are searching a single numerical value. So linear search int list. That means we pass out for the function list of arrays, and one element or one single int numerical value, integer value, one variable. So the function takes two items, one array and one target key. So as you can see, ctd int n is equals to 7 you can minimize into 6 or 5, whatever. The array size that is 7. Int main, inside the main method, int list of n is 7. Then we create 7 element of array. Int k is the key that we want to search from the list. Then enter the key you want to search from the key from the array. Cnk, that means assume you take one value or one integer number, just like for Brim game. Mr. X, please call one number from 1 up to 10. That means you have 10 candidates that Mr. X wants to or can call. So from 0 up to 10. Please call one number. That is the key that we want to find from the array. So this is k. So please enter that k, cnk. Then enter the array list. After that, enter the array using the for loop. We enter or we give list of items from the user, from the keyboard. That means from the keyboard. Just using for loop, cin list of j. J starts from 0 up to n. N is 7. Then 7 item or array elements we pass to the array. Then next int I is equals to linear search of list, comma k, pass to call the function. If I is equals to -1, see out the search is not found. Else the search is found at index I. This is the way how we code. But directly pass to the main target. How create that function to find that target value. This is the main the method or the function that we create to search that target key. So what we do is linear search into list of arrays as a parameter and the key. And index is equals to -1. Initially, we didn't know what is the key. We didn't know, so the key is not announced. That means it is -1. We take or initialize as -1, and in the for loop, I start from 0 up to n. I plus increment. Search the key is matched to the from the list of arrays or not. So if list of I equal to k, list of arrays equal to k, assume the entered key, the entered element is here. Assume list of arrays 7 elements or items we pass 0, 1, 2, 3, 4, 5. Divide it into 2. I think now I can get 7. 1, 2, 3, 4, 5, 6, 7. This is 7 spaces created to hold your list of arrays. So assume 7, 9, 1, 2, 11, 13, 6, 7. This is the list of arrays. It may be sequential, ordered or not ordered, linear or sequential searching starts from the lowest value and checks or compares each value with your key, starting from index 0. So what you have to do here is that list of I equal to key, list of I starts from 0, then list of 0 equal to key. What's the key? Assume nobody can't know what is the key, meaning key is equals to let 5. If the key equal to 5, assume we want to search this 5 value. Actually 5 is not found here. 6. By the way, you can search the empty or not included values or items and can return -1 if the item is not found in the list. So just assume the key or the required number is 6. Then how we check that 6 is found in the list or not, and where is it found, at what index. So what here we do, list of 0 equal to 6. List of 0 meaning 7. Is 7 equal to 6? No. If no, what we have to do here? If list of I equal to key, no. Therefore, if this statement is not executed or not satisfied, just we pass to increment the values of the I inside the for loop. So I became is plus plus, I equal to or increment from here I is equal to 0, here I is equal to 1, and check again. List of 1 equal to 6. List of 1, what is list of 1? 9. 9 equal to 6. Is it right? No. Again, this is false. And we pass to I again and increment the I. I equal to what? 2. I equal to 2. And check. List of 2 is equals to list of 2 equal to list of 2 equal to 6. Is it right? What is list of 2? List of 2 is 1. 1 equal to 6? No, wrong. Then what is next? Back again and increment I became is what? 3. I equal to or I is equals to 3, and list of 3 equal to 6. List of 3 is what? List of 3 is 2 equal to 6? No. Again, no. Pass increment I equal to what? 4. List of 4 equal to 6. List of 4 meaning 11 equal to 6? No. Back to your for loop and increment I becomes what? 5. Is list of 5 equal to 6? List of 5 meaning 30. 1 3 equal to 6? Question mark? No. Again. Back again to your actually, yeah, this is visible. I think it is visible. So increment again I is 5 here. We plus I is equals to 6, and the list of 6 equal to 6. List of 6 meaning 6. Actually by default the index and the target value is the same, 6. So list of 6 is 6 equal to 6? Yes, definitely. So we got the required target key that we want to search from list of the array or from the list of the elements. So the index is equals to 6, key is equals to 6. So how we display it? Index is equals to I, break. If list of I is equals to key, that means 6 is equal to 6. Yes, 6 equal to 6. So we got the key, the required number. So what we have to do? Index is equals to I. That means I is 6. Break. If we call the break keyword here, it automatically turn out from the loop and also turn out from all loops. And how we display it? Look, this one. Int I is equals to linear search list comma k. So if I equal to -1, I is not -1. Because we got the index. If this is satisfied, index is equals to -1. Unless index is I is 6. So in the calling function here, list and k, we pass list and k as a parameter. If I equal to -1, no. So the else statement is executed here. The value is found at index position I is index in the position that we got. The key is at index 6. So this is the output. So return 0, inner search, we pass it, and it is implemented using this way. Linear search or sequential search is implemented in this way.
First, we include the header file and declare the prototype function of the linear search. We pass list of arrays and the target key. as I told you. And this is the main method. Starting from this up to this, yeah. So here, if the key search array place enter, then we enter here and check or accept the list of arrays using this for loop list of j. We accept, and when we call the list linear search function and execute to search the target key. After that, if the I equals to minus 1, that means found is equals to minus 1. The item is not found unless I is different from minus 1 or greater than minus 1. It returns the index of the required key with that of its value. And this is the linear search function. The linear search function. So as I told you, from the prototype of the function, we pass list of arrays and the target key or the required key item. Then index is equals to minus 1 at the first time, and starting from 0 as the first index up to the end of the array. We check if the list of I is equal to key. If it is equal, or the key is equal to at one index of or somewhere in the array list, then index is equal to I, or the index of that key were found or that item were found. Then return index. So just directly past how it implements. Just we execute it and look the output.
Okay, guys, just to show the implementation, the simulation, run the codes that we see on the presentation. So when we run it and give some values, just enter the key you want to search from the array, assume the 6, and enter what list of values that you want to search. The list is maybe 4, 1, 2, 12, 3, 1, 6, and 7 here. So the value is found at index 5. The value is found at index 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, at index 5 meaning 6 item. Look this one. This is how it works. The value that we give is the first array list is 4, 1, 2, 12, 3, 6, and the last one is 7. This is the array we pass to our list value or array value. So 0, 1, 2, 3, 4, 5, 6. 6. So the 6 index value is 6. Why? Because the first one, the required target key is equals to 6. So at fifth index, list of 5, that means 6 equal to 6 is satisfied, or this statement is true, then the target is found. Actually, if your key is not found in your list, until the end of the top or the n-1 index is continue. The search is continue until the end of your list or your arrays. Unless, what I mean, finally, if the list is not found in your list, the index is -1. Then -1 implies the key is not found in your list. This is the definition or how linear search is implemented using the C++ programming language. Thank you for today's video. Thank you. Please like, share, subscribe. Don't forget.